All right, so let's check out one last FRQ. Here we have a function f that's given analytically. We also have a function g given numerically as a table. And we have a function h given graphically. So we want to first find the slope of the line tangent to f. So we need to find the derivative. All right, so for this first one, we want f prime. And f prime is going to be the derivative of the cosine of 2x, which will be negative 2 sine of 2x, plus derivative of e to the sine of x will be cosine of x e to the sine of x, right? So using the chain rule properties for each of them. And then I want at x equals pi. So f prime at pi is going to be negative 2 sine of 2 pi plus the cosine of pi times e to the sine of pi. Now, we need to know that the sine of 2 pi needs to evaluate. That's 0. The cosine of pi is negative 1. And once again, the sine of pi, that's 0. So what that gives me then is 0 minus e to the 0. So negative 1. Okay. Continuing, let k be the function defined. Find k prime. So it looks like we're going to be using the chain rule here. So k prime is going to be the derivative of the outside, keep the inside, times the derivative of the inside. So that means that k prime of pi is going to be h prime of f of pi times negative 1, because we found that negative 1 was the value. So now we need f of pi. So that's going to be h prime of, well, f of pi is going to be the cosine of 2 pi, which is 1, plus e to the 0. So that's going to be h prime at 2 times negative 1. Okay, so h prime of 2. So now I need to come to h, find x equals 2, and I need to find the slope of this line. And the slope of that line seems to be negative 1/3. So I'm going to have negative 1/3 times negative 1, and that means that k prime of pi is going to be positive 1/3. M is defined. Find m prime of 2. So just a lot of practice with derivatives, right? So m prime is going to be product rule, which will be g of negative 2x multiplied by h prime of x, right? Then plus h of x multiplied by g prime of negative 2x times negative 2 using our chain rule. So at 2, we're going to have g prime, or not g prime, because it's just g to start with. So g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. So let's come to our tables. All right, so h prime, the slope we knew was negative 1/3. We also need, what is it? G of negative 4. So g of negative 4 is 5. So this is going to be 5 times negative 1/3 plus h of 2, the actual value at 2. So let's see here. Slope of negative 1/3, so that's going to be an actual value of negative 2/3. A little bit of math there. G prime of negative 4, so come over. G prime of negative 4 is negative 1. So times negative 1, and then times negative 2. And as long as I have all of my right values in all of my right places, I'm good. All right, so 5 times negative 1/3 and negative 4/3. If I do that, that would be -3, -9/3. But all the right numbers in all the right places is good enough. Then, is there a number on the closed interval such that g prime of c is -4? Well, let's see here. G is differentiable, and it's talking about g. So, g is differentiable, so therefore continuous, on -5 to -3. So therefore, by the mean value theorem, there is a number c in the closed interval such that g prime of c equals -4. All right. Now, why -4? Well, because really this is saying that our instantaneous rate of change needs to equal our average rate of change. So we want to find and make sure that g of -3 minus g of -5 all over -3 minus -5 is going to be equal to -4. So let's come back to our table. G of -3, g of -5. So what we've got is 2 minus 10 divided by 2, and that is -4. So we do have, by the mean value theorem, and whenever you have a mean value theorem, you know it if you're talking about a differentiable function and you want to find out about the slope of that function being equal to the instantaneous rate of change. So where are our points for this one? For this one, 2 points over here. G is differentiable by mean value theorem. So we had to have that. IROC equals AROC, having it evaluated correctly. Have to have that, 2 points. All right, for part C. Part C actually has 3 points. Did I do the product rule for the first part? And for the second part. And then lastly, do I have the right value? So really and truly, this is one where you should get all 3 marks, but it might be that you just get 1 because of a careless error, or maybe you get 0. So please be careful with all of your product rules and quotient rules and chain rules. For part B, finding K prime correctly is 1 mark. Getting the correct value is 1 mark, so there's 2 marks there. And then same, finding F prime correctly, getting the right answer, 2 marks. Okay, so the more adept you are at your derivatives, the more success you will have on these assessments of your knowledge and application of calculus concepts. All right. Thank you very much for your time. Best of luck to those of you that will be taking the AP exams or other exams. And for those of you that are just doing a review, if you have questions, please do ask.